this expression you can see there's a cubic form in the denominator, and that is x cubed minus 4x squared plus x plus 6. Sorry, just like in the previous two examples, you need to factorize this first. But you can see in the second example it was much easier, but here you have to spend some time to factorize this. But it's not difficult. You have to follow 2 more steps. Let's do it. First, you have to get the rational roots theorem. So it means you have to focus on the x cubed term and the constant term. So x cubed term, you have to get the coefficient of x cubed, and here it's just 1, and I'll name it as an. So an is 1. Now the constant term, so it's 6 here, so I'll name it as a0, so a0 is 6. Now we have to find out the factors of an and factors of a0. So the factors of an is just 1 again, and factors of a0 is 1, 2, 3 and 6. So there are 4 factors. So now we have to divide the factors of a0 by the factors of an. So here I'll put it as a0 over an, but truly it means the factors of a0 by factors of an. So here the first factor, first one is 1. So a0 is 1 and an is always 1. So 1 over 1 is 1. Same as that, for the next 3 factors, 2 over 1 is 2, 3 over 1 is 3, 6 over 1 is 6. So these can be positive and negative values. So what I'm going to do is just substitute these values, the negative forms and the positive forms of these values, into x and find out whether the whole expression goes to 0. So let x equals 1 means that if x is 1, 1 cube minus 4 into 1 squared plus 1 plus 6. So you have to check whether it's equal to 0 or not. So here it's not 0. So it means x can't be positive 1. Now the negative one. So if x is minus 1, it means minus 1 cube minus 4 into minus 1 squared minus 1 plus 6, and that is 0. So the whole expression goes to 0. It means x can be minus 1. So x plus 1 is equal to 0. We just found a 1 factor. You don't need to repeat the whole process for all the factors, the negative forms and the positive forms. You don't need to do that. You just need to find out 1 factor and just go to the next step. So the next step is the long division. You have to divide the whole expression by the factor you found. So here the expression is x cubed minus 4x squared plus x plus 6. So the factor we found is x plus 1. You have divided it by x plus 1. So this is a simple long division. It's easy. So x cubed, we have to eliminate the x cubed term first. So it will be x squared. So x squared into x plus 1 is x cubed plus x squared. So get the difference and you'll get 0 minus 5x squared. You can see there are 2 more terms remaining, and that is x plus 6. Just drag it down, and now let's focus on minus 5x squared term. So I have to eliminate that. So it is minus 5x into x plus 1. So that is minus 5x squared minus 5x. Get the difference and you'll get 0 plus 6x. And plus 6 is remaining again. So just drag it down, and here it's 6x plus 6. So factor we found is x plus 1. So if we multiply it by 6, we can eliminate the whole thing. Remaining whole stuff is 6x plus 6 or plus 6. 6 into x plus 1 is 6x plus 6. So you'll get the difference as 0. Now you got x plus 1 and x squared minus 5x plus 6. So here it's a quadratic function. It's really easy to find out the factors. So the factors of x squared minus 5x plus 6 is x minus 2 and x minus 3. So you just found the whole factors for this expression, that is x cubed minus 4x squared plus x plus 6. So that is x plus 1, x minus 2, x minus 3. So there are 3 linear terms. Sorry, not just in partial fractions. Anywhere you found this kind of expressions, if you need to find out the factors, you can follow these 2 steps. And it's easy to find out the factors. So here there are 3 linear terms we found, and you can use these terms to split this whole expression. I mean the whole expression, the 5x squared minus 15x minus 8 divided by x cubed minus 4x squared plus x plus 6 into partial fractions with the constant terms of a, b and c. So let's move to that. You'll get a over x plus 1 plus b over x minus 2 and c over x minus 3. But still, you need to find out the values of a, b and c. So you can use these 3 fractions furthermore, and you'll get a into x minus 2 and x minus 3 plus b into x plus 1 x minus 3 plus c into x plus 1 x minus 2. So with the common denominator as x plus 1, x minus 2 and x minus 3. So we are going to use the method equating coefficient terms and constant terms in both sides, or you have to focus on the numerator values first. In both sides, the left hand side is 5x squared minus 15x minus 8, and the right hand side is 8x minus 2, x minus 3 plus b into x plus 1 x minus 3 plus c into x plus 1 x minus 2. So as usual, these 2 values are equal. So you can use that with a further simplification of the numerator value in the right hand side, and that is loads and loads of x squared terms, x terms and constant terms. So let's focus on the x squared terms first. So in the left hand side there's only one x squared term, and that is 5x squared. And the right hand side there are 3, ax squared plus bx squared plus cx squared. So the coefficient in the left hand side is just 5, and the right hand side is a plus b plus c. So 5 equals a plus b plus c. And that is my first equation. Same as that, let's focus on the x term. So in the left hand side it's minus 15x, and the right hand side it's minus 5ax minus 2bx minus cx. So the coefficients in the left hand side is just minus 15, and the right hand side is minus 5a minus 2b minus c. So minus 15 equals minus 5a minus 2b minus c. You can see all the terms are in negative form. So you can write it in positive form. So 15 equals 5a plus 2b plus c. So that is my second equation. Let's move to the constant terms. So the constant term in the left hand side is minus 8, and the right hand side there are 3 terms, plus 6a minus 3b minus 2c. So minus 8 equals 6a minus 3b minus 2c. So that is my third equation. Now we have 3 equations. Simply simplify these 3 furthermore. So I'm going to get the difference between the second equation and the first equation. So 15 minus 5 is 10, 5a minus a is 4a, 2b minus b is b. So c will be cancelled off. So you'll get 10 equals 4a plus b. So you can substitute either B or A. So I'm going to substitute B here. So B will be 10 minus 4A. Well, I'm going to substitute value of B into equation 2. So 15 equals 5A plus 2 into 10 minus 4A plus C. So let's substitute the C here. So C is 3A minus 5. Now we know the value of B and the value of C with the term of A. So simply substitute those two values into equation 3. So you'll get minus 8 equals 6A minus 3 into 10 minus 4A minus 2 into 3A minus 5. So A will be 1. Now we know the value of A. So B is 10 minus 4A. So B will be 6. And C is 3A minus 5, so C will be minus 2. With the terms of A, B and C, we got the partial fractions as A over x plus 1 plus B over x minus 2 plus C over x minus 3. So you know the values of A, B and C, so simply substitute those values and you'll get the partial fractions as 1 over x plus 1 plus 6 over x minus 2 over x minus 3.